Okay, let's see 18. Okay, let me put my gloves on for this. So question 18, we need to solve for a system of inequalities. So she calls compound inequalities. So just like the linear equations, right? If we put two equations together, we call system equations. So personally, I like to call this system of inequalities. Erase this, get my pen back. So I have this inequality, and we know how to solve. And then we have this inequality, right? So solve this one, we move -2 to the other side. We have 5x less than or equal to. Move -2 to the other side. So it's 3 plus 2, right? So it's 5, which means x is less than or equal to 1. And, right, so we have this solution. Let's graph it to make it visual. 0 sits in the middle. Let's see, 1 is here. X is less than or equal to solid dot. If no equal sign, only less than, we make an empty circle, right? All this less than, so heading towards negative infinity. So that's a solution for the first inequality. For the second inequality, we do the same thing. We move +7 to the other side, becomes -7, right? So 3 minus 7, that's -4. 4x greater than -4. So 4x greater than -4. We divide by 4 on both sides. So x greater than -1. Well, let's graph this one. So -1, let's see, -1 is here. So x is greater than -1, open circle, because no equal sign with it. But it goes the other way around, because it's greater than, so it goes this way, heading towards positive infinity. So and means the intersection of those two solution sets. And, right? Versus or. Or is the union of the two sets. This is the and. And means the overlapping, means the solution for both. That's this. So the solution set is from -1, not including -1, up to 1, including 1. So we could use this set notation or interval notation. Not including -1, we use open parentheses. Including 1, we use bracket. Okay, so either one. Now let's say the second one is or, right? Okay, let's think about this. If the first one was or, the solution set would be all real numbers, all right? Where you see, goes from 1 down to negative infinity, goes from -1 up to positive infinity, so covers all real numbers if the question were asking for or. Let's say second one, B. Solve this inequality, we get x greater than 5. Solve this one, excuse me. So we like to divide by 3 on both sides. So we divide by 3, we get x minus 1/3 less than a divided by 3. So we move -1/3 to the other side. It becomes x less than a divided by 3 plus 1 divided by 3. Well, 1a plus 1, that's 9. 9 divided by 3, that's 3. Right. So let's see, let's draw this graph. So let's see, 0 here, 3 here, 5 here. So the first solution is x greater than 5. So we make an open circle, greater than, heading towards positive infinity. X less than 3, also no equal sign, open circle, heading to negative infinity because it's less than. If this were asking for and, there would be no solution because those two solution sets has no overlapping part. but this is asking for or. Or means unit. If we use interval notation, we would do from negative infinity, because we always go from left to right. Negative infinity up to 3, not including 3, union 5, not including 5, heading towards positive infinity. So all the values down less than 3 or bigger than 5 works for this, for both of this, for the or. Okay, or means either work for this one or works for other one, as long as the solution is for one, it's okay. So comparing to and is different. And means the solution has to work for both inequalities. Or means as long as the solution works for one of it. Okay, now let's see 19. Absolute value function. So we have 2 multiplied by the absolute value sign. So what do? We want to get rid of these 2. How do we get rid of these 2? We divide by 2 on both sides. 10 divided by 2, we get 5. So we're left with absolute value inside 3 minus 4x equals to 5. So 2 cases where absolute value means inside can be positive or can be negative. So the first case, so we always have to, we'll suppose, have 2 solutions. Unless it's 0. If the solution is 0, we only have, well, let's see. Let's see this one. So 1 is 3 minus 4x is positive. Right? That means equal to positive 5. So we solve for this. We have negative 4x equals to 5 minus 3, which is 2. So divided by negative 4, we get negative half. So x equals negative half is one solution, right? When 3 minus 4x is positive, or the second situation is 3 minus 4x is negative 5. And then after the absolute value sign become positive 5. So 3 minus 4x equals negative 5. We solve this and get it. Negative 4x equals to minus 5 minus 3, that's negative 8. Divided by 4, negative 4 on both sides, so x equals 2. 2 solutions. All right. Because this absolute value, this has to be positive or 0, right? Non-negative. But the x itself, the inside x itself can be negative, it can be positive. Okay, let's see 20. I just realized, I have tonight, so now it's 12 o'clock at night already. I'm very sleepy, but I want to finish as more as possible for you. And tomorrow I have some volunteer work until 3 o'clock in the afternoon. But I have to eat lunch. My son's home, so we're going to go out to eat lunch. Then after that, I'm going to keep working on this, hopefully by tomorrow night. Tomorrow is Tuesday, right? Tuesday, I don't have class anymore, so all the classes finished. So by tomorrow night, I should be able to finish everything, all right? All right, so 20, solve and graph this inequality. So comparing to the top previous one, we have 2 variables now. So how do we graph this? It's different. This is 2 dimension, right? Comparing to 19 and 18, this is 1 dimension world, right? We only have 1 variable. But here we have 2 variables. That means we're in 2 dimension world. We have x value and a y value. So what do? First, we graph the line 5x plus 2y equals to negative 8. Even this is greater than negative 8. So we're going to graph the line first. So graph this line, we only need 2 points. So we just assign x some easy values. Let's say x equals 0. If x is 0, so 5x is gone. We have 2y equals negative 8. So we get a 0, negative 4 at 1 point. If x is 1, 5 times 1, that's 5. Move 5 to the other side, become negative 5. So you know what? Let's do -1 actually. Let x be -1. -1 times 5 is -5. -5 move to the other side, become +5. We'll get into fractions. So we add 5, -a plus 5, that's -3. So if we do -1, we get -3/2. So 2 points, we can draw this line. X-axis, y-axis, 0, -4. Let's see, this is a -4. So I have this point. Then -1, let's see, -1 is here for x. Then -3/2. So let's see, this is 2. So 3/2 is that's 1/2. So we get all these 2 points. Okay, we get a point here, somewhere here, right? So let's pray I can draw a very straight line. Oh yes, the computer, it helped me. Oh, okay, not so good. Okay, so we draw this line first. I should draw dotted line. You know why? Because this has no equal sign. This is only greater than. So I'm going back to my eraser to erase some of it. Oh, okay. Go back to my pen. All right. Sorry, that's my son. He's hungry. He's eating. Okay, I should draw dotted line, right? Because my inequality has no equal sign. It's only greater than -8. So I have drawn this line with a dotted line. Now, because this sign is greater than, so where I'm going to find my solution? My solution is all above this line. This is my solution sets, all above this line, because all the y value is greater than the value on this line. If it was less than, I would shade it down the line, all right? So this is my solution set. Usually you can shade it or you can put an S on it to mean the solution set. So comparing those 2 dimension and 1 dimension, right? 1 dimension just with an arrow, solid or open circle towards a positive infinity or negative infinity. But in 2-dimension world, we have an area of solutions because we have X value, we have Y value. We're in 2-dimension world. Okay, that's 20. And 21, we have this 2. So we're going to look for intersection. So when we put this as a system, right, we put 2 inequalities as a system. So we need to find, we're going to draw one with vertical lines, another one with horizontal lines. Then we look for the grades. The grades, if you find the grades, that means the overlapping of those 2 solution sets. So let's see the first one. So let's draw the first one. So same thing, I'm going to draw x minus y equals to 5, right? I just need 2 points. If x is 0, I get y equals to -5. Let's see, -5 is somewhere here. If y is 0, I get x equals to +5. So this is my, oh, also I need to draw dotted line, all right? So just imagine those are dotted line. Then what I'm going to do with this, so I draw the line. Okay, I should talk more about the A first, all right? So the greater than, so we follow greater than y because this 2y is positive. But here, look at this. This is a negative y. Negative y greater than 5, that means y less than something, right? Positive y less than something. So we pay attention to the sign of the y. If this is positive, greater than, So we graph this way. But for this one, it's negative y greater than. That means positive y less than. Let's see if it makes sense of this. So negative y greater than something means positive y less than the same thing. So if it's less than, I draw down below the line. I shade it below the line, which means all the y value less than the y value on this line is in my solution set. So that's the first one. For the second one, also I draw the line. Let me change my color to be blue so we can tell which is which. Okay. I may not remove this one smoothly yet. Okay, I'm gonna do the same thing. I need to find 2 points. If y is 0, I get x equals to 2. Okay. I need a rest actually. I'm so tired. My brain doesn't work anymore. Let's say 2 is here because 5 is here, 2, so it should be here somewhere. So that's y equals 0. Right? If x equals 0, we have y equals -4. -4 is very close to -5. So I have these 2 points. So just hope I can draw a straight line. Oh, yeah. Okay, this keeps going. Right. So now I look y, negative y. It's a negative y less than. Negative y less than means positive y greater than. Okay, make sure you do this. Make sure you check y is negative y or positive y. If it's positive, like this one, like A, we just follow the sign. If it's negative y, we flip the sign. All right, and y. So that means y greater than. So that means all the values above this. So where's our intersection? Our intersection is difficult to see it because it's here. You see the down below the red, and also, oh, actually no, because let's see. Yes, will be down below this green, the blue one and the red one. So it'll be somewhere here. So that's our solution set. Okay, that's 21. 22, subtraction polynomials. Okay, so I have a little trouble to move this pen. Okay, so this is subtraction, right? So some people like to do this. Some people, so the first parenthesis, we can just ignore it. We can just ignore the first parenthesis. So let's take off the second parenthesis. So negative times negative, that becomes positive. And negative times positive, that becomes negative. Negative times positive, that becomes a negative. So no more this parenthesis. So we have 4x cubed minus 2x plus a plus x cubed minus 3x squared minus 6. So 4x cubed plus x cubed, that's 5x cubed. Plus minus 3x squared. So we want to write in order. In order means the exponents in decreasing continuation. Then the x term is we have minus 2x. Then plus a minus 6, we have plus 2. Okay, that's for the first one. The second one, we have this binomial multiplied by the trinomial. So we distribute, we multiply 2x squared with negative x squared. We multiply 2x squared with 2x. We multiply 2x squared with negative 1. So let's write here. So 2x squared times negative x squared is negative 2x raised by 4. X squared, 2x squared plus times positive 2x, that's 4x cubed. Then 2x squared times minus 1 is 2x squared. Then we multiply 6 with all three terms, right? So 6 times negative x squared is negative 6x squared. 6 times 2x, that's 12x. 6 times negative 1 is negative 6. So let's see. So only those two are like terms. We combine those two. So we have negative 2x raised by 4 plus 4x cubed minus, so we add those two. That's negative ax squared plus 12x minus 6. That's it. So this is for 22b. 22b, we multiply a binomial with a trinomial. So 23 factoring. The first one, we have 4 terms. So with 4 terms, usually we group 2 by 2. We group those two, we group those two. Then we factor out the common factor. So the common factor of the first group is x squared. Right, then we have 2x minus 1. The second one, we see 2 is a common factor. We also have 2x minus 1. Now we have 2x minus 1 as a common factor. So we write 2x minus 1 times what's left for the first term, x squared. What's left for the second term, just 2. Now you see the 4 terms becomes in a factored form. Okay, the second one, x raised by 6 minus 64. We want to use difference of 2 squares. So x raised by 6, we can write as x cubed squared. 64 is a squared. So we get x cubed plus a times x cubed minus 8. Have we finished? No, we see 2 cubes, right? X cubed plus 2 cubed. So sum of 2 cubes and the difference of 2 cubes. So sum of 2 cubes is x plus 2 times x squared plus 2 times x plus 2 squared, which is 4. Difference of 2 cubes is x minus 2 times, oh, hold on. This is a minus sign, right? When this is a plus, this is a minus. When this is a minus, this is a plus. So x squared plus 2x minus, excuse me, plus 4, okay? So what do we have? We have x plus 2 times x squared minus 2x plus 4 times x minus 2, x squared plus 2x plus 4. Okay, you see, those 2 terms factored out to be 4 factors. So why we want to like to be in factor form? Because we want to solve equations. You see like this one, right? Definitely we want to put this in a factor form, then you can apply zero property. Zero property is saying if we have factors, then they're equal to 0. That means each factor can be 0. So how do we factor this one? We see 2x squared, there's only one way to factor, right? 2x and x. Then minus 5, there's only 2 ways, either minus 5 times plus 1 or positive 1 times negative, positive 5 times negative 1. But if we want to somehow to get the middle term, get the middle term to be negative 9. So how do we do that? We probably want to multiply 2 with negative 5, because we get negative 10. Then plus 1x. You see, this tells you middle term. 1 times x, 1x. 2x times negative 5, negative 10x. So negative 10x plus x, that's negative 9x. So this is factored into 2 factors. So by zero property, each factor can be 0. So 2x plus 1 equals 0. That means x equals a negative half. Or x minus 5 can be 0. that x equals to 5. So two solutions. Okay, 25. So I'm gonna finish up to 26. I need to go to sleep. So A, the object is thrown upward ground height. So you see this is a function h of t, right? Function h of t. So downward parabola, right? You see t squared, that tells you that's quadratic. Negative 16, leading coefficient is negative. So you know this parabola goes downward. Right? Then how long will it be? How long will it be before the object hits the ground? Okay, what's the height? Imagine the ball is being tossing. But when it reaches the ground, what's the height? The height is 0, normal height. So that means this guy is just 0, right? This is 0. So I have negative 16 t squared plus 64 t equals to 0. We just have to solve this quadratic equation. So let's divide by negative 16 first. So we want to make this one positive, right? Minus, so 64 divided by negative 16, that's negative. Well, 64 is 4 cubed. 16 is 4 squared. So 64 divided by 16, that's 4. So t squared minus 4t equals 0. Factor out t, we want to put in a factored form. So t times t minus 4 equals 0. So we get two solutions. Either t equals 0 or t equals 4. So which means before you do anything, the ball is on the ground. So if you toss the ball to the air, after 4 seconds, it will hit the ground again. So two solutions. Let's see 26. We want to find the domain of the rational function. So in mathematics, we don't do two apples shared by nobody. Doesn't make any sense, right? So we don't divide by 0 in mathematics. So this does not exist in mathematics. Or you can see this is illegal in mathematics. So when we have a rational functions, expressions, or equations, because the variable appears in the denominator, so certain values of x may make the denominator to be 0. So what do? We take the denominator, whatever it is, in this case is x squared plus 5x minus 6. We say, okay, that cannot be 0. Because if this is 0, denominator is 0, it does not exist in mathematics. So it's set not equal to 0. Now we try to solve this quadratic equation. So x plus 6 times x minus 1 cannot be 0, right? Because you see the middle term, 6x minus 1x, that's 5x. So that means x equals to negative 6 and positive 1. So two solutions. Or the domain will have, so what do we see? That's not equal to, okay. I'm so sleepy, I started to, see nonsense. So the domain is x can be any number, but not negative 6, not 1. So we put not equal to sign. Okay, x not equal to negative 6 or 1, but can be any other values. All right, I'm gonna finish this. I need to go to sleep. And so tomorrow I'll finish, hopefully, I'll finish the rest of it.